Morning, Dr. Shekhar and my fellow friends. Today I'm going to present about our mini project Embedded. So our title is Interfacing 7-segment display with PIC microcontroller. My group member's name is Sharmela Sundar 10TEP19 F1005, Sharvina Subramaniam 10TEP19 F1015, and my name is Suthaseni Ravi 10TEP19 F1030. The purpose of our project is can be used in our daily equipment where it can be used digital clocks at our home or at the electronic meters at our workstations. This project also can be used to countdown or a timer with playing games. The internal features that we have used for our project will be timer and interrupt. This is our coding for interfacing 7-segment display with PIC microcontroller. So we using PIC 16F1517 for our mini project. So I'm going to explain you one by one which is standing for. So we using 20 million UL. We start with config 1. Pragma config FOSCHS is standing for oscillator selection, HS or oscillator, high speed crystal or resonator connected between oscillation 1 and oscillation pins. Second one is Pragma config WTE equals to off. That is for standing watchdog timer enable, WDT disable. Third one is Pragma config PWRTE equals to OFF. It's standing for power up timed enable, which is PWRT is disable. Pragma config MCLRE is on. It's standing for MCLR pin function select, which is pin function is MCLR. Pragma config CP is off. That one is flash program memory code protection. Program memory code protection is disabled. And the next is Pragma config Boring is on. Brown out reset enable. It's standing for brown out reset enable. And the next one is Pragma config CL Cowton equals to OFF. It's standing for clock out enable, which is function is disable, and the IO or oscillator function on the CLK out pin. IO means it's input and output. And the next one, Pragma config IESO equals to on. The internal or external switchover. Internal or external switchover mode is enabled. And the last one in config 1 is Pragma config FCMEN equals to on. Its fail safe clock monitor enable is enabled. Alright, the next one is config 2. Pragma config WRT equals to off. It's standing for flash memory self-write protection. Write protection is off. Pragma config VCAPEN equals to off. Its voltage regulator capacity enable bit. So the next one is Pragma config STVREN equals to on. Its stack overflow or underflow reset enable will cause a reset. The next one is Pragma config LPBOR equals to off. Low power brown out reset. Pragma config BORE is LO. It's a brown out reset voltage selection. And the next one is the last one in config 2 is Pragma config LVP equals to off. It's standing for low voltage programming enable. At this task and following tab, this Harris Toss binary bit pattern that will be sent to port D with common cathode 7-segment display unsigned char sec x standing for 0 times 3f, 0 times 06, 0 times 5b, 0 times 4f, 0 times 66, 0 times 6d, 0 times 7d, 0 times 07, 0 times 7f, 0 times 6f, and 0 times 00. And this last part standing for the port D equals to 0x00, the set port D as output, and trace D 0 times 00 defined as port D as a output pin, while this loop sends all hex value to port D for I equals to 0 and Moreover, and the port D sec X delay ms is 500 with 0.5 second. That's all for our coding.
So this is our mini project circuit using Produce. So we use PIC 16F1517, and our title for this project is Interfacing 7-segment display. So we use crystal 7-segment common anode and 2 capacitor, a resistor, and ground and power. So for the port D, you will be connecting all the port D, RD0 to RD6 to the resistor, and then you'll be connecting the next wire to the connected terminal, and the ground to the segment common anode ground leg. So there will be connectivity, and you'll be adding crystal, and the first leg of the crystal will be connected to the RE6, and the second leg of crystal will be added to the RE7, and lastly add power supply to the RE3. So when you run the simulation, you can see that the 7-segment common anode will be running from 0 to 9. So you can be seeing when I run stimulate it. So as you can see, we can use this in our daily life. Example, we can use this as a timer. So it will be very beneficial for everyone to use as a daily life. We can use this as a stopwatch too. So that's all for our circuit diagram using Produce.